In this lesson, we discuss user data nodes, which are really interesting judging by what they can do. Let's say I have a standard surface shader in my scene applied to these three objects, but I want to have different base colors, specular weights, specular roughness, reflection colors for each object. So one shader, but with different properties for each object. That sounds interesting. Let's see what we can do. So first, let's create a new standard surface shader. Apply to the clock, the sphere, and the abstract object, and run the IPR. Now open up the shader. On the left side, you can find user data nodes. You have user data float, integer, RGB, RGBA, and string. We talk about this object shader later on in the lesson. For the first step, let's see if we can use three different colors as base color for these three different objects. We are dealing with color, so let's bring in a user data RGB node connected to the base color of the standard surface shader. If I select the user data RGB node, you can see we have two options, attribute and default. In the attribute field, you need to write a name which best represents the attribute you are trying to control. In this case, it is base color, so let's type, I don't know, B color, all in small letters. You can type anything you want. Now we need to add the same attribute to our object. So starting with the clock, select it in the attribute manager, user data menu, and click on add user data. Select this data and change the name to B color, change the data type from float to color, and press OK. Now I have a new tab called user data and a color attribute. Let's use this pinkish color. As you can see now, the base color for the clock is pink, and the color for the sphere and the abstract object here is pure black. And this black color is coming from the default color in the user data RGB node. So if I change this default color to something like red, they would have this red color by default if we don't assign a color attribute like we did with the clock. So let's select the clock and select the B color attribute, right click on it, user data interface, and copy user data interface. Now select the sphere again, user data menu, and paste user data interface. And now we have this B color data, and we can press OK. Let's use this bluish color. And as you can see, we have this blue sphere. Let's do the same thing for the object. So select the object, user data menu, paste user data interface, and press OK. And let's use this purple color. So even though we have the same standard surface shader applied to all the geometries, but we have three different base color for these three objects. Now let's select the standard surface shader node. Open up the specular section. I want the same user data RGB node to control the specular color of these three objects as well. So let's connect the output of our user data RGB node to the specular color of the standard surface shader as well. And I'm going to set the IR to something like 5, 6. And now if I increase the specular weight, you see we have three different specular colors for these three objects. Now let's say I want to have three different specular weights for these three objects. So for this, we need a user data float node. So drag it to the work area. For the attribute, let's type SW for specular weight, or type whatever you want. And let's connect it to the specular weight of the standard surface shader. Now select the clock from the user data menu, click on add user data. Let's rename this data to sweight, or SW, sorry, and change the interface to float slider. So here you can see we have a slider. I'm going to change the unit from percent to real. The maximum number for specular weight is 1, so let's change the max number to 1. And right now, if I try to change my slider with the mouse, I can only go between 0 and 1. So let's change the step to something like 0.05, so we can get a smoother slider, and set the default value back to 0 and click OK. Now we have a SW attribute. for the clock, and as I increase it, I increase the specular weight of the clock separately from my other objects. I can right click on the SW from user interface submenu, choose copy user data interface, select the sphere and paste user data interface. Let's move it down so it's after the B color, and let's do the same thing for the abstract object. Now I can have different specular weights for these three objects. So let's set the specular weight for the clock to 0.2, set the specular weight for the sphere to 0.65, and 0.85 for the object. So one standard surface is applied, but now we have three different shaders in the scene, and we still can go ahead and do the same thing with other attributes. Maybe you can try to make the clock refractive without changing the sphere and the object. Also, we have the object user data, which lets you to reference a parameter of an existing object in the scene, and this can be really fun. I'm going to quickly show you two examples. I have this extra sphere in the scene that is simply named object. For the first scenario, I want my three main geometries in the scene to have two shaders, a plastic shader and a gold shader. Whether they would be rendered with the plastic or the gold shader will be based on the visibility of this sphere object in the render. So when the sphere is not visible in the render, we'll get the plastic shader, and when it is visible, we will get the gold shader, or vice versa. Let's use the sphere object as a reference geometry in the object shader. And the parameter we want to use is visible in render. Now, visible in render is either true or false. So if the object is visible in the render, the shaders output 1 or true, and if it is not, it outputs 0 or false. Let's add a standard surface shader. The default look is fine. I'm going to add a new standard surface shader, and for this one, use the gold preset. Now add a switch shader and set it as the beauty shader. Switch shader allows you to switch between the shaders that are defined as its inputs. When I use the white shader as input 0 and the gold shader as input 1. Now when the index of the switch shader is 0, we get the white shader, and when it is 1, we get the golden shader. Instead of doing it manually, we want this value to be based on the visibility of the sphere. So connect the output of the object shader to the index input of the switch shader. Now if I turn off and on the visibility of the object in the render, we will get the white standard surface shader or the golden shader. Now for the next example, I want to have a shader that as I move the sphere on X to right for 100 centimeter, the shader base weight becomes 1. So when the sphere is positioned at 0 on X, the base weight will be 0. And as we move it to 100 centimeters on X, the base weight will become 1. I'm going to copy the object shader. And this time we want to export position. Now this node exports a vector on X, Y, and Z. We are only interested in the X position, so we need a node to convert this vector to three float values, which are X, Y, and Z. We don't have a vector to float node specifically, but we have an RGB to float, and RGB can be considered a vector as it has three values. Depending on whether we deal with floating point RGB values or smaller range, that's something for another place. For now, just consider the RGB to float a vector to float node. And now in the RGB to float node, we can decide which channel we want to extract or which axes. Let's get R for X position. You can do the same thing for the Y position if you extract G or green, and for Z position, it would be blue. For now, select red. Now we want the X position to be from 0 to 100 centimeter, while the base weight is from 0 to 1. So we need to change that range. I'm going to add a range node after the RGB to float node. The incoming range is from 0 to 100. And we want that to be from 0 to 1 for our base weight to work. Now connect the range output to the base weight input of a standard surface shader, and set the standard surface shader as the beauty shader. And now if I start to move the sphere on X, the base weight will start to increase. And when the sphere is at 100 centimeters on X, the base weight is 1. But if I start to move the sphere on X more than 100 centimeters, the base weight will start increasing proportionally. So basically at around 200 centimeter, the base weight will be 2. But we want to clamp the base weight to 1. So basically add a clamp node after the range node and change its mode to scalar and connect the clamp shader to the base weight input. Now the base weight will start to increase as we move the sphere on X. When the sphere gets to 100 centimeter on X, the base weight will become 1. And after that, if we move the sphere even more on X, the base weight would remain at 1. And if you wanted to increase that range, simply go to the range node and increase that 100 centimeter to more than that. So that's how you can use user data nodes, and still there is a lot you can do here, but that's enough for now. See you in the next video.